Okay, we're now on to the worked examples in the textbook. And to be honest, right, it's just kind of going through what we've learned now on surds. If you watch my previous videos in the playlist, this is actually probably a little bit easier. I think the questions here are almost easier than what we've been through already. But, okay, there are some nice questions nonetheless. This first one, let's go through it. We've got, right, root 8 plus root 2 in the form root a. And actually, just by looking at this, you've got to be a little bit careful because it's not saying write it in the form k root 8, which is what we think it might be. Like, you can't have a number with a surd. It's just going to be a surd on its own. Anyway, the question is basically just saying here, simplify, first of all, root 8, because root 8 we can write as root 4 times by 2. Simplifying surds, which we've seen before, which is going to be equal to root 4 is 2 times by root 2, so 2 lots of root 2. So root 8 is equal to root 2, and we are adding on to it that root 2, so we're adding on root 2. And 2 root 2 add 1 root 2 is equal to 3 root 2. And this is what I mean, right? It's saying put it in the form root a. So there should be no number before the surd. Currently, I've got 3 times root 2, which is in the form k root a, okay, where k is the number. So I've got to get this as a single surd. So I've kind of got to reverse this 3 now. Well, how can I write 3 so it becomes a surd? 3 is actually the same thing as root 9. Okay, root 9 is equal to 3, and I'm timesing that by root 2. Okay, so usually, right, we just simplify it and write it like this. This question is being a little bit crafty. You've almost got to sort of unsimplify it again, which is a bit strange. But 3 is equal to root 9, and then we know from our laws of surds, right, this part down here, it is just simply saying that you've got the root of one surd times by the root of another surd. We can write it as a singular surd, the two numbers times together. So that's going to be equal to root 18, because 9 times 2 is 18, so this is actually your answer. That is in the required form. Root a, you've got a single surd with your number in that surd. Quite a nice question, actually. A little bit of a trick in there. Okay, example number 2.9. If you've looked at my videos on expanding brackets, this will be a piece of cake for you, hopefully. Okay, right, it says expand or simplify 1 plus root 2, all squared. What we're on 2.9, so if we write it out in full, we've got 1 plus root 2, we're squaring it, we're timesing it by itself, so 1 plus root 2, expanding brackets, first by first term, multiplying first by second, second by first, second by second, 1 times by that 1 gives you 1, you've then got 1 times by root 2, it's going to be plus 1 root 2 or just plus root 2, you've then got a root 2 times by 1, which again is just plus root 2, you've then got a root 2 times by a root 2, which is root 4, so plus root 4. So overall, we can simplify this a bit further because, well, root 2 and root 2 are like terms, so we're going to be getting 1 plus, you've got 2 lots of root 2's, so you've got 2 root 2 there, the green parts, and root 4, okay, is simply equal to 2, so you've got plus 2 on the end. But you can simplify it further because, well, what's 1 add 2? It is simply equal to 3, so this is equal to 3 plus 2 lots of root 2. So that is your answer, fully simplified. You can't simplify it any further because root 2, you can't break it down any further. And you definitely cannot combine 3 and a root 2. That's your answer. Good. Okay, example number 2.10. Right, this should be a piece of cake. If you look at my video on rationalizing the denominator, it says rationalize the denominator of 2 over root 3. So you want to manipulate it so the surd is not on the bottom and it's on the top. And we do this, okay, we've got 2 over root 3. We do this by timesing the top and bottom by what the surd is on the bottom. So root 3 over root 3. Because remember, this is effectively, well, it is the same thing as 1. Root 3 over root 3 is equal to 1. You're timesing the whole fraction by 1. You're keeping it the same. That's why you can do that. Now, what is 2 times root 3? We simply write it as 2 root 3 over what is root 3 times by root 3. You can just write it as root 9, so over root 9. So it's going to be 2 root 3 over root 9 is equal to 3. So this is your answer, 2 root 3 over 3. Perfect. This one looks a little bit trickier, but again, we've seen it previously. We've seen similar examples on the previous video, I think it was now. Yeah, so you want to rationalize, you want to get rid of that surd, manipulate the surd on the bottom to get it onto the top. So if our fraction is we've got 3 over 8, take away 2 lots of root 3, we want to multiply the surd fraction, sorry, top and bottom by whatever the number is on the bottom, but you want to change that sign because then you get the difference of 2 squares and the surds will cancel out. So we're going to times everything by 8 plus you change the sign to root 3 over 8 plus 2 root 3. And again, right, this is effectively timesing it through by 1 because 8 plus 2 root 3 divided by 8 plus 2 root 3 is 1. So you're just timesing this by 1, you're keeping it the same. It's a legal move to do. Now, if we go and consider the numerator part, okay, this part, let's go and do it down here. Let's go and consider the numerator part, numerator. So we're doing 3, we're timesing it by 8 plus 2 lots of root 3, expanding a single bracket, nice and easy for us. 3 times by 8 is equal to 24. 3 times by 2 root 3 is going to be plus 6 root 3. So that's the numerator part. Good. We've then got the denominator part, okay, which is 8 take away 2 root 3 times 8 plus 2 root 3. Now, if you wanted to, you could go and expand out the double brackets, but the whole point of this, or timesing by the 8 plus 2 root 3, is you get this, which is the difference of two squares form. This is in the form, let's write it over here, a plus b, bracket a take away b. It's in your difference of two squares form, and we know if we expand brackets in this form, you get a squared take away b squared. Right, where a in this case, right, a is equal to 8 and 8, you can see that. So a is equal to 8, and your b part, okay, is equal to b part is 2 root 3, 2 root 3. So b is equal to 2 root 3. So what's a squared going to be? Well, a squared is going to be 8 times 8, which is 64. Okay, what's b squared going to be? Well, 2 root 3 times by 2 root 3, 2 root 3 squared, timesing it by 2 root 3. 2 times 2 is 4. Root 3 times by root 3 is root 9. So that's equal to 4. Root 3, 9 is 3. 4 times 3 is equal to 12. So it's going to go to a squared, which is 64, take away b squared, which is 12. So it's going to be 64, take away 12, which of course is equal to 52. So 52 on the bottom. So we know that this is going to go to simply 52. You could have gone and expanded the brackets using FOIL, this by this, this by this. You don't need to. If you can in maths, you've got to be crafty. You've got to save yourself time. Okay, good. So overall, on the numerator part, we got 24 plus 6 root 3. Okay, so we had 24 plus 6 root 3, all being divided by 52. And I'm not sure how the book has written it. It might have simplified it a little bit further. Yeah, I think it has done, hasn't it? What's it done here? Yeah, okay, so what it's done here is, right, this is correct. This is absolutely fine. But you can simplify it further because 24, 6, and 52 are all factors of 2. Sorry, multiples of 2. So we can go and divide everything, divide the whole shebang by 2. Okay. Therefore, right, this is going to be equal to 24 divided by 2 is 12. 6 root 3 halved divided by 2 is going to be 3 root 3, so plus 3 root 3 over 52 divided by 2 is equal to 26. So this, they mean the same thing, they're the same answer, but that is your simplified answer. Excellent. So again, both of these are definitely rationalized, but you want to write it in its simplest possible form. 24, 6, and 52 are all divisible by 2. There we go. Good. Okay, let's zoom out a bit so you can see the full thing. Good. Okay. Is that it? That's it. Okay, so, right, next video we'll be looking at getting onto the textbook exercises. Brilliant. Okay, fantastic. We're really zooming through this. Okay, thank you for watching. Brilliant.